Hello guys and welcome! I hope that you're doing well. My name is UHDking, or I play 4K, aka I play 8K, aka I play 16K, and during this video we're going to talk about Dirt3 PC game running in 12K video resolution, 12K UHD, that will be formed out of the 3 8K resolution screen in vertical mode. So as you can see, I'm recording this video with Nvidia ShadowPlay. Throughout this video, we're going to go through all kind of different presets. So this test was done without Nvidia ShadowPlay recording. Right now, I'm going to do the same test within the Nvidia ShadowPlay recording. So we are going to find out how much FPS were lost. So 87 FPS average, as you can see, minimum FPS 71 FPS. Keep that your eye at those values. At the left top corner, as you can see, the values right there is self-explanatory, updated every single seconds. FPS stands for frames per second. MS stands for the milliseconds, which is milliseconds latency delay between every single frame is rendered between the GPU video RAM, CPU system RAM, and operating system Nvidia driver, operating system Windows 10 Professional Nvidia driver, and DirectX 11 API in our case. This is going to be Dirt3 PC game complete edition. That means that it's having all kind of DLC, but it doesn't matter. It's going to be the same thing under the benchmark. So 12K video resolution on a single Titan RTX video card and Intel Core i9-9900K overclock at 5.3 GHz, but with only 6 physical cores enabled, 6 physical threads is enabled. In the end of this video, I'm going to go throughout my PC configurations, system specs, etc., and some other tests, some additional information. So 12,960 pixels by 7,680 pixels. So as you can see, I'm using the 8K video resolution 16 divided by 9 aspect ratio, which is 7,680 pixels as my height, and then the build up out of the 3 8K screens displays 12,960 pixels on my width. So we're going to start with the low preset. This is how I tested ultra low preset, and let's go ahead and bench it real quick again and then compare the FPS. So you're gonna find out exactly how much the Nvidia ShadowPlay consumed and lower our FPS. So then we're gonna use it as percentage while we're gonna add additional FPS to the FPS counter while I'm recording in real time. I decided to go ahead and share with you guys in real time. This is going to be the world's first 12K video resolution in Dirt3 PC game. Keep in mind this is almost twice as 8K in all kind of ways. And yeah, let's go ahead and have a look what we can achieve here. 16K video resolution will be 4 8K screens in a normal mode, and right now it's almost the same, but 3 8K resolution screens but in vertical mode. But real estate of the pixels is amazing over here, guys, going on, as you can see. So great FPS, above 60 FPS average, actually above 70 FPS average, latency delay below 20 milliseconds, so the gameplay status will be comfortable. As again, this is ultra low preset, the minimum visual preset that is possible in Dirt3 PC game. Titan RTX video card is overclocked to the maximum potential through the software in home safe environment. As you can see, GPU utilization on the left top corner 99%, sometimes dropping to 98 a little bit, but still utilizing almost all the CUDA cores on a Titan RTX video card and a Turing GPU architecture by Nvidia. TU102 GPU will be total 4,608 CUDA cores, 100% or 99%. This is going to be the utilization. So I would say we are at least utilizing 4,600 CUDA cores for sure. The CPU utilization will never bring to 50% of overall CPU utilization, and this is a clear sign. We want to keep the CPU utilization as low as possible, but GPU utilization we want to keep 97% and above, like 100% is the excellent or 99% is the excellent GPU utilization, and this is exactly what we are receiving right now. So average FPS 79 FPS, or so I would say it's exactly like 6% loss throughout the recording with Nvidia ShadowPlay. So go ahead and add around 6% to the FPS counter to the left top corner. So average FPS 79 FPS, minimum FPS 66 FPS. So we went from 86 to 79. We lost like 7 FPS. So almost 10%, but just because we started with 86, so I would say like 7-8%. At least add 6% to the FPS counter to the left top corner to get the real FPS. Alright, so let's go ahead and check out some other presets real quick. I'm going to check the low preset because there is a big difference between the ultra low preset and low preset when we are talking Dirt3 PC game. So let's go ahead and check it out. As you can see, it's updating and refreshing the presets in real time in this particular game, so I don't have to reboot the game. So this is going to be the low preset now. Let's go ahead and bench it. I'm coming in real time. I'm using the artificial intelligent voice removal, that removing the noise out of my mic. Keep that in mind, and it can distort my voice a little bit. Okay. So video RAM utilization is almost 18,000 megabytes. Wow, the video RAM utilization while running 12K resolution is actually higher in Dirt3 PC game when compared to 16K video resolution, and I'm not sure why, but I already recorded, guys. Today is December 2022 for those who's curious, but this type of technologies was available to us in December 2018, but I already recorded the 16K video resolution. It is available over the UHDking.com. But this is going to be the first video uploaded, so it's going to be the world's first 12K video resolution, the first video above 8K video resolution rendered in real time natively in Dirt3 PC game, and then I'm going to upload 16K video resolution. But you're gonna see that video RAM utilization under the 16K video resolution with the same preset will be below 16,000 megabytes, and right now we are almost 18,000 megabytes video RAM utilization, and I'm not sure why. Maybe just 3 vertical 8K screens in vertical mode is kind of complicated complications, I would say, for the Nvidia algorithms while it's rendering in real time and rasterizing the pixels through the rasterization pipelines. There is a possibility, but as again, the video RAM utilization is higher than it was under the 16K video resolution, and I'm not sure why. But as again, I'm pretty sure that we're rendering right now natively 12K video resolution. In the end of this video, I'm going to demonstrate it for you, indeed, that we're rendering natively 12K resolution. And I'm pretty sure that during that test, I natively was rendering 16K video resolution. Maybe just because 3 8K screens in vertical mode for this particular game. It never happened before with any other games. Only in this game, the video RAM utilization under the 12K resolution is a little bit higher than under 16K video resolution. As again, not sure why. Anyways, average FPS 60 FPS, minimum FPS 49 FPS, almost 50 FPS. And as again, we just did the low preset. Let's go ahead and switch to a medium preset. The visuals is amazing under the 12K resolution, even at the low preset. Just unbelievable, great, guys. Visuals. So medium preset now. Let's go ahead and do that. Let me make sure it's refreshed this presets. 12K video resolution is again medium preset. Let's go ahead and keep going. I'm drinking the hot chocolate and coffee in premix, kind of fancy. But you gotta stay away from drinking a lot of coffee, because what I find out, a lot of coffee is unhealthy for you guys. So I'm going to limit myself now on coffee. Look at this medium preset now. As you can see, we increased in terms of the radius preloading, in terms of the level of details. Right now it's looking absolutely amazing. Please watch this video in 4320p in your YouTube player or in 8K UHD. Just switch in your YouTube player to 8K UHD or 4320p. I'm recording today with the modified Nvidia ShadowPlay, that recording in 8K video resolution even on Turing GPU architecture. And Turing GPU architecture was the first video card that the first GPU architecture that was supporting Nvidia ShadowPlay in 8K video resolution natively, recording and encoding. But unfortunately, Nvidia didn't represent to us through the Nvidia ShadowPlay, through the Nvidia game experience, and I believe maybe they decided to introduce to us through the EVGA GPU architecture while introducing the RTX 4000 series, and RTX 4000 series officially supporting 8K video resolution through the Nvidia ShadowPlay. But it's using the AV1 different video encoding codec. Keep that in mind. And this is the old school Nvidia video encoding codec, but it's still great and still capable to record in 8K video resolution. Actually, when it's recording, it's less than 8K resolution in terms of the pixels. It's creating an extra black space to it. But as again, the quality will be amazing when compared recording 8K video resolution Nvidia ShadowPlay versus 4K video resolution. And it's going to be 100 megabit per second, so go ahead and switch in your YouTube player 4320p and enjoy. As again, as you can see, video RAM utilization is above 18,000 megabytes but below 19,000 megabytes, so pretty much 18 gigabytes of video RAM is required right now to be able to run medium preset with 12K resolution. The system RAM utilization is a little bit above 14,000 megabytes but below 15,000 megabytes, so still system RAM 16 gigabytes will be more than enough. But I put the system RAM for you to have a look with your eye every time, just to check if we are floating some data from the video RAM into the system RAM, because when you're going to see that system RAM will jump, that's a clear sign that we are floating some data from the video RAM into the system RAM. Alright, so 12K video resolution, 3K, 3x 8K screens in vertical mode, medium preset, Dirt3 PC game, average FPS 37, minimum FPS 32, and as again with Nvidia ShadowPlay recording, please add 7% or at least 6% to the FPS counter in every second. So let's go ahead and switch now, and I'm going to go ahead and switch now to high preset, and we're going to go ahead and test high preset now. Okay, as you can see, it's updating in real time. The presets, visual presets, which is neat for this particular game, which is Dirt3 PC game. As again, Titan RTX running to the maximum stable overclock through the software in a home save environment. So pretty much right now you're watching, guys, most likely probably the best performance out of the Titan RTX video card. On a 13900K Intel CPU, you're going to receive maximum 15% boost, and it depends to the games, but it's going to be maximum 15% boost, 15% boost. Keep that in mind, not that much, maximum maybe 3-4 FPS extra. I'm also going to test two Titan RTX video cards in SLI in this particular game. If this particular game will support SLI, it should. DirectX 11 API and Dirt Rally PC game supports SLI, so hopefully Dirt3 PC game supports SLI as well. And if it will be the case, I'm going to demonstrate it for you over the UHDking.com that you don't want to miss. So probably 16K video resolution will be playable experience, not only the benchable experience but playable experience. The game looks great at high preset 12K resolution. It just looking much better than Dirt Rally PC game, which was the much newer game. Keep in mind that Dirt3 PC game was released back in 2011, and it's running the EVGA game engine, same game engine that was powering F1 and Grid PC games as well, and all kind of Dirt PC games. But this is not the updated version, but still looking great. The visuals are unbelievable for 2011 PC game, and I know a lot of people still playing this game with the steering wheels, pedals and such, and this is, guys, the best video for you. And as you can see, I'm sharing the great information above 8K video resolution when everything is looking so photorealistic, and this game feels so great, especially when you're riding with the steering wheel and such. So a lot of people still running it, and go ahead and smash the like button if you're one of them. Share it with your friends. 12K resolution is possible. All what you gotta do, set 3 8K resolution screens in vertical mode and enjoy. And if you're gonna do it with the above 70 inches 8K resolution TVs in vertical mode, you're gonna enjoy like, oh my god, the real estate was going to be above 200 inches, and it's going to be a playable FPS, as you can see, guys, even at the high preset. So high preset 36 FPS average, minimum preset minimum FPS will be 30 FPS, as again at the high preset, which is almost the maximum visuals. Let's go ahead and switch to ultra preset now, and ultra preset will be the maximum visuals possible, and then I'm going to start playing with some anti-aliasing if we're not going to overload the video RAM. Hopefully we're not going to do that, but we're going to find out. So 12K resolution ultra preset, let's go ahead and have a look. Okay, so this is the maximum visuals without any anti-aliasing, and we're still below 20,000 megabytes or below 20 gigabytes of our video RAM utilization. but the visual is going to look just fantastic under the ultra preset in 12K resolution, much better than 8K video resolution, and you can tell the difference 12K resolution or 16K video resolution even when it's running DSR. So it's rendering natively in that resolution. This is not the upscale, it's rendering natively 12K resolution and then it's downscaling and outputting the signal to 8K resolution screen. Keep that in mind, to a single 8K resolution screen. This is the case right now in this scenario, but you can connect 3 8K resolution screens at 30 Hz to a Titan RTX video card. It's supported, but 60 Hz is not supported for the port that is equipped on the Titan RTX video card or RTX 2080 Ti video card, which is same Turing GPU architecture. RTX 2080 Ti video card will have 256 CUDA core less than Titan RTX video card, but as again, it's only equipped with 11 GB of video RAM, and it's not possible to run with a single RTX 2080 Ti video card or 2 RTX 2080 Ti video cards in SLI. Do that is going to overload the video RAM. Okay. And in SLI, the local video RAM is used for that local GPU. You cannot, share the video RAM on that array of the SLI array. Each GPU, local GPU, requires its own local video RAM. Alright, so almost 20 FPS average without the recording is going to be for sure 20 FPS average. Video RAM utilization below 19,000 megabytes, so below 19 gigabytes. Great. The latency delay is like 60 milliseconds on average. System RAM utilization below 15,000 megabytes, so there's no changes in system RAM. So when you're gonna see the changes in system RAM, that's a clear sign that we are floating some data in from the video RAM into the system RAM. So average FPS 19 FPS, minimum FPS 17 FPS, great result. So 2 Titan RTXs and SLI can run this playable experience for sure. And this 12K resolution is hair off from 16K video resolution when 4 8K screens in regular mode. Keep that in mind. Alright, so what I'm gonna do now, I'm going to go ahead and start playing with the anti-aliasing. So we're gonna go ahead and start 2x MSAA. Okay, let me skip that. It's going to take it. I'm going to confirm. As again, I'm running in Windows mode because after 8K video resolution, it has the flickering shaders, the textures, and you must run it in Windows mode, especially for 16K video resolution. So I'm going to test 8K resolution, 12K resolution, 16K video resolution in Windows mode, so we can compare in terms of the performance. So a lot of valuable data is shared with you guys throughout this video, so don't forget to smash that like button. So ultra preset, completely ultra preset, 2 times MSAA. Let me, before the ultra preset, let me go ahead and actually real quick try the ultra low. For those who's curious, it's going to be an additional piece of information, the ultra low instead of ultra, but with the 2 times MSAA. Okay, I'm just real quick just gonna throw this test just for those who's curious. Okay, and let's go ahead and bench it, and then I'm going to do the ultra at 2x. I will try to do the ultra at 4x as well, ultra low at 4x, such as ultra and maximum ultra at 4x, and then so I will try to do the anti-aliasing at ultra low preset just for those who's curious, just to show you the difference. But it's looking great, guys. And you don't need to have anti-aliasing at 12K resolution if you're running at 100%, and even if you have the real estate of the screens like above 80 inches. Below 100 inches screens, you're not going to see any difference when you're running anti-aliasing or not. But this is going to be in terms for the benchmarks, the data, because the future video cards will be much powerful, and we're going to be limited by this EVGA game engine. So I'm trying to lower my FPS natively, organically, so we're gonna see, so we can compare with the performance, because I'm pretty sure that RTX 4090 video card will show here at least 3 times more FPS that you can see right now. I would say if it's going to be utilized 97-99% on RTX 4090 video card, either GPU architecture, I'm pretty sure that over here we're gonna show like almost 200 FPS average at this type of preset right now. And at one point we're gonna be limited by the EVGA game engine, and I think the maximum FPS probably like 1000 FPS if I'm not mistaken, when it's unlocked, the whole FPS unlocked, uncapped. But just to be able to test the future video card from 2025, such as RTX 5000 series, RTX 6000 series, that's why I'm complicating the presets. while you can compare the ultra low presets with your not the flagship video cards from 2023, such as not the Nvidia RTX 4090, but let's say Nvidia RTX 4070 or even Nvidia RTX 4060 Ti, which will be the best video card in 2023, RTX 4060 Ti, guys, because it's going to show same performance as a Titan RTX video card, single video card, but it's going to pretty much show it a little bit better. Keep that in mind, even a little bit better. Anyways, average FPS 54 FPS, minimum FPS 46 FPS. Great results with 2x anti-aliasing, ultra low preset. Let's go ahead and have a look now at the ultra preset, which is maximum visual preset, 2x anti-aliasing. It's going to be nice to see that. Let's go ahead and have a look at that. So this maximum visuals with two times anti-aliasing by MSAA, which is not a joke, which is real anti-aliasing, guys. And as again, we're not sure how developers is applying this method of anti-aliasing. Maybe not to everything on the scene, but maybe to everything on the scene. They only know. I gotta look at the binary, not the binary, but actually the whole code to find out. But I can assume they're applying that anti-aliasing method to a lot of elements while it's rendering in real time on our 3D port, and it's not going to be a problem for Turing GPU architecture such as Titan RTX video card, as you can see. And as again, Titan RTX video card is the first video card in the world that was available to the gamers that is capable to run Dirt3 PC game above 8K video resolution in a benchable condition. Due that it's featuring 24,000 megabytes, a little bit above 24,000 megabytes, which is 24 gigabyte of video RAM, GDDR6 by Samsung, the same memory that featured GDDR6 by Samsung on RTX 2080 Ti video card, which is also Turing GPU architecture. But as again, that video card is only limited to 11 gigabyte of video RAM, and everything was limited to 12 gigabyte of video RAM before, as a flagship, before the Turing GPU architecture, before 2018, such as Titan X Maxwell GPU architecture flagship by Nvidia was limited for the gamers by 12 gigabyte of video RAM, and then Pascal GPU architecture for the gamers was limited by 12 gigabyte of video RAM, but Volta was featuring a little bit more of video RAM. Then Volta GPU architecture Titan V, I also had the Titan V, was limited to 12 gigabyte of video RAM, but it was the CEO edition that was limited, I believe, to 24 gigabyte of video RAM, but it was available only to a short amount of people, and it was not for sale. Keep that in mind. So could be actually the Volta, Titan Volta was the first GPU, because Titan Volta is almost similar in terms of the performance as Turing GPU architecture to the Titan RTX, but Titan RTX will be like about, I would say, maybe 15-20% faster, stack to stack at least, than Titan V, Titan Volta. But there is a possibility Titan Volta also can run this, but as again, not the regular Titan V, but Titan V CEO edition that was featuring 24 gigabyte of video RAM only, as again, limited edition. So average FPS 18 FPS, minimum FPS 15 FPS, great results. So let's go ahead and switch to 4x, and I'm going to start 4x, but this time we're going to do the, as again, ultra low preset, just for the lowest possible visuals, just to see how it's going to do. Let's go ahead and do that. And apply. As you can see, it's applying the settings in Dirt3 PC game on the fly, so I don't have to reboot. So 4 times MSA, ultra low preset. Let's go ahead and have a look. This is crazy stuff going on over here, guys. Let's go ahead and have a look what we have over here. And that coffee is great, guys. We're gonna have one of the coldest days in the history very soon, in few days. Okay, so let me see. We're running, guys, right now over 100 megapixels rendered in real time, and just because it's rendering, as you can see, about 40 FPS, that means that we're running about 4 gigapixels per second right now. The amount of total pixels will be 4 gigapixels per second, but to be exact, per each frame is going to be 102 megapixels. So 16K video resolution, the array out of the 4 8K screens, will be 132.7 megapixels, and right now we're running 102 megapixels, so we're about one 8K resolution screen, because we are only running 3 8K resolution screens in vertical mode, and it's going to be exactly that 34 megapixels we're lacking before touching that 16K video resolution. But we are still above 100 megapixels per second for each frame. Keep that in mind, rendered frame, and it's just unbelievable performance, guys. Hero from 16K video resolution, not far away. Beautiful performance. As you can see, video RAM utilization right now jumped above 21,000 megabytes, so above 21 gigabytes. The system RAM utilization is also jump out to almost 16,000 megabytes, which is 15,450 megabytes right now. So I can assume that we offloaded around 1 gigabyte of the video RAM into the system RAM, just to be sure, because NVIDIA driver cannot predict it well, so it's predicting in the future, and then start offloading the data in the future without overloading the NVIDIA driver and crash the game into the blue screen. So it's going to start offloading the data. Usually on Titan RTX video card, throughout my test, it happens after 20,000 megabytes. It's already thinking when it's offload the unnecessary data from the video RAM into the system RAM, that is not going to crash the game, and game is still going to be runnable and at great FPS. Kudos to Nvidia, by the way. Anyways, average FPS 50 FPS, minimum FPS 41 FPS, great result. This is the 4 times MSAA with the ultra low preset. Let's go ahead and switch now to ultra preset, which is the maximum visuals. Okay, apply that, and let's go ahead and have a look. So ultra visual preset, 4 times MSAA. Let's go ahead and have a look, guys. Cannot wait to test this game with 2 Titan RTXs and SLI, as again, SLI supported under DirectX 9, DirectX 10 and DirectX 11 API. SLI is not supported under DirectX 12 API because Microsoft decided to go a different approach. Instead of SLI and Crossfire, it decided to integrate the universal multiple GPU support, but software developers, game developers are too lazy to integrate it in every single game. But it's available through the DirectX 12 API, guys, as pre-built classes for them to use. They're just too lazy to do that. And Nvidia decided not to support SLI because the DirectX 12 API doesn't support SLI. Okay, and developers can integrate the multiple GPU just using couple classes, so Nvidia doesn't need to release any SLI profile. So they completely make sense. I support Nvidia. So they decided not to waste their time if the developers, game developers, doesn't want to waste their time while integrating the multiple GPU capabilities with a few lines of code. Anyways, almost 22,000 megabytes of our video RAM utilization, but still below 22 gigabytes. System RAM utilization is almost 16,000 megabytes, but still below 16,000 megabytes. But I can say that we are floating at least 1 gigabyte from a video RAM into the system RAM. About same video RAM utilization as 12K resolution at ultra low, 4 times MSA, versus the 12K resolution 4 times MSA at ultra, which is the maximum visual preset. Almost the same. I would say we increased by about 200 megabytes more in terms of the video RAM utilization. Beautiful visuals, guys. As again, this game looks amazing. The game from 2011 in above 8K video resolution is just unbelievable. Such a great experience. If you into Dirt3 PC game, you want to experience this, guys. This is just unbelievable. And hopefully you're gonna do it with a single RTX 4090 video card that will deliver at least 3 times more FPS, and you can connect 4 8K screens at 60 Hz at least, while on Titan RTXs, again, you cannot connect 4 8K screens at 60 Hz. It can only be 4 8K screens at 30 Hz. Okay, but as again, it doesn't matter what is the hertz of my screens right now on the output signal of the cable. It's still going to be the same performance no matter what is the screens refresh rate that you're running. Anyways, average FPS 18, minimum FPS 15. Alright, let's go ahead and increase. We're gonna go ahead and increase now the anti-aliasing to 8x. There is a King anti-aliasing which will be 8xQCSAA, but it is unstable and is crashing, overloading the video RAM under the 16K video resolution. Most likely it's going to do it under the 12K video resolution, but let me demonstrate first 8x MSA, and we're going to find out if we're going to run the King anti-aliasing method under the Dirt3 PC game. But as again, it doesn't matter. It doesn't. Those type of different methods of anti-aliasing will be almost the same when compared. So 8 times MSAA, and I'm going to start with the ultra preset, ultra low preset, which will be the minimum visuals. As again, great CPU benchmark test, but just because it's 12K video resolution, it's also great GPU test as well. Look at this. I think we're frozen with 8 times MSA. Let's go ahead and see if it's going to unfroze. Yep, look like the same screen, but I don't see the difference. Let me quit that. Let me quit the game. We're going to reload the game. It helped under the 16K video resolution. It happens like this when I'm recording with Nvidia ShadowPlay. I didn't record with Nvidia ShadowPlay. It didn't do that under the 8 times MSA with 12K video resolution. So somehow Nvidia ShadowPlay is somehow utilizing, as you can see, some of the components that is available on Titan RTX video card that is involved in the rendering in real time in the Dirt3 PC game. But hopefully it's going to take these presets, and hopefully, yep, look like it did, but hopefully right now we are running those type of presets, visual presets. I think we're going to reach to the maximum of the video RAM utilization by about 23,000 megabytes, a little bit below than 23,000 megabytes with 8 times MSA. But this is still a great achievement for a single Turing GPU architecture by Nvidia, for a single Titan RTX video card that is running today. The secondary Titan RTX is removed into my different system, keep that in mind, to avoid any hot air pockets. So let's go ahead and have a look. The presets. 8 times MSA, yes, it took it. It's going to be ultra low preset. Let's go ahead and run it, guys. Ultra low preset, 12K video resolution. Alright, let's go ahead and have a look. So as you can see, we are increasing in terms of our video RAM utilization immediately, almost to 21,000 megabytes. I'm pretty sure we're going to increase it throughout the scene, 3D scene rendering in action. The system memory utilization is still below 13,000 megabytes. GPU utilization is excellent. CPU utilization jumping from 5300 megahertz sometimes to 5200 megahertz because I'm running 52 multiplier on AVX2 instruction frequency, and for the nature of the Intel driver and Intel 9000 series CPUs, it's jumping from the maximum external frequency to the AVX2 instruction frequency. We do that AVX2 instruction frequency is always slower than maximum external frequency, and Intel driver doing that just to cool down the CPU and to use the low voltage on the CPU as V-core, and cooling down the CPU, limiting that hot temperature, and it's doing that when you're not going to when it's not going to be beneficial based on Intel driver, and I cannot control it. So that's why you want to keep your AVX2 instruction frequency to the highest maximum stable frequencies, closest to the external maximum frequency, to achieve the maximum boost in terms of the performance when we're talking Intel 9000 series CPUs only. Keep in mind the scenario will change to when we're talking 11,000 CPUs, 12,000 CPUs, and 13,000 CPUs. Intel will introduce actually some different technologies. But anyways, look how small my mouse cursor right there in the middle. This is unbelievable. 12K video resolution, and indeed my desktop is set to 12K video resolution. Otherwise, do not run it into windowed mode because you're not going to deliver that performance. My desktop is set to same 12K video resolution, and in the end of this video I'm going to demonstrate it for you. Anyways, below 21,000 megabytes, the video RAM utilization right now even lower. I think the garbage collector didn't clean itself on the previous test, because as again, that's why I think under the 16K video resolution the video RAM utilization now makes sense, but previous tests it didn't make sense. I think after the first benchmark, the garbage collector, when I switched in terms of the different presets, didn't clean itself right, and we were showing some video RAM utilization when we didn't utilize it, but it was in the garbage collector. And now after the game reboot, we actually cleaned that, and right now I believe we are showing the true real video RAM utilization under the 12K resolution, because it's, when compared to 16K video resolution right now, is lower and completely make mathematical sense. So average FPS 43 FPS, minimum FPS 34 FPS, great result. This is 8 times MSIA with the ultra low visual preset. Let's go ahead and change the preset to ultra preset, which is the maximum visual preset. All right, let me accept that, and let's go ahead and verify that. So 8 times MSIA, ultra preset, maximum visual preset. Let's go ahead and have a look. Great performance, as you can see at the left top corner. Almost 22,000 megabytes of our video RAM utilization right now, and this is pretty much the top of the top. This is 8 times MSA anti-aliasing. As again, I can switch to that King anti-aliasing method, but as again, this is going to be the same type of visual experience to the user. But that type of anti-aliasing will use a little bit more of the video RAM utilization, but the visual experience will be almost the same. When zoom in, I'm going to demonstrate it for you. But anyways, almost 22,000 megabytes of video RAM utilization, but still below 22,000 megabytes. Under the 16K video resolution, it is going to be above 22,000 megabytes with the same preset. And as again, 16K video resolution, 16K video resolution benchmark in Dirt3 PC game will be available over the UHDking.com. You don't want to miss it. Go ahead and check it out. And also check out the 8K video resolution benchmark, but as again, the FPS will be very high, but just for those who want to compare with the slower video cards, and such as RTX 3060 Ti video card. Great FPS, guys. Still below 22 gigabytes of video RAM utilization. Excellent CPU utilization, not bottlenecking throughout our threads. Only bottlenecking throughout the frequency per instruction per clock, because the higher frequency, the more instruction per clock, even with the outdated CPU architecture. But newer CPU architecture can bring even higher instruction per clock at the same frequency. Which will be reflecting as we will be running this all outdated 2018 technology at the higher frequency to reach that performance instruction per clock. Hopefully, guys, this makes sense. I just explained to you all kind of different details from those beginners, as PC hardware enthusiast, PC overclocker, graphics designer, 3D artist, software developer, game developer. Average FPS 16 FPS, almost 17. Minimum FPS 13. This is the maximum visual preset, guys. This is just unbelievable. 12K video resolution. So what I'm gonna do right now, I will try to show you above for those who's curious, just in case, like that. And let's go ahead and start with the ultra low. Maybe we're gonna overload our video RAM, maybe not. Let's go ahead and have a look. I'm gonna say yes. Everything is frozen. So I'm going to reboot the game. Yes, everything is frozen, as you can see. Hopefully it's gonna take these settings. Let me reboot the game. Maybe we are overloaded our video RAM to the point when the game is not going to be loading correctly. But I'm pretty sure, guys, 16K video resolution with this type of anti-aliasing method, the game is not loadable. It's pretty much going to be black screen, or the red screen, or the green screen, whatever, and it's not updating, not refreshing in real time. But let's see, this is the king way of the anti-aliasing, the last preset. Let's go ahead and have a look if it's going to be possible or not. Hopefully it's sipping something nice and warm, such as tea, great tea, or yeah, it's a black screen as well, guys. Nope. It should be animation here instead of black screen, but I think it's going to be a black screen. Nothing will happen. Let's go ahead and have a look. Yeah, it's black screen. This is the same scenario under the 16K video resolution. So this type of anti-aliasing method is unavailable for Dirt3 PC game. for 24 gigabyte of video RAM utilized by the Nvidia GPU architecture in 2018, and I'm pretty sure in 2022 or 2023 after the EVGA GPU architecture is going to be the same scenario for 24 gigabyte of the video RAM, because Nvidia texture compression method probably is not going to change, and most likely it's going to be improved by 10%. Maybe after 5 years it's going to utilize a little bit less of the video RAM that is today in 2022. And AMD Radeon video cards will be utilizing less video RAM for sure, by about 30% less, keep that in mind. But do that, AMD is using different texture compression methods and a little bit different approach through the rasterized pipelines on those AMD video cards. Anyways, it's impossible, guys, but I demonstrated for you everything what you need to know. Hopefully it didn't shut down my video recording. Hopefully it's still recording. So for those naysayers, let me first of all demonstrate that my display settings is 12K video resolution natively in real time. This is very important to set it. 100% scale, 12,960 pixels by 7,680 pixels, which is 102 megapixels rendered in real time. Check it out. This is under 1600%, and look how everything is so clear and nice. If you're gonna do that 1600% zoom into 4K video resolution, everything will be so pixelated. But it's again 102 megapixels, 102 megapixels rendered in real time, 100% display resolution scale. It doesn't matter for a lot of games, like in 90% of the games, but some games doesn't scale right if 100% scale is not set. Let's say when it's 500%, as again above 90% will scale right, but some of the games are not scaling right, and the scale ratio on the resolution most likely used for the font size of the scaling, and some games heavily related to that throughout the game engines, and they're not scaling right. But as again, only below 10% of the games. That was tested by me in 16K video resolution, which is the maximum video resolution that is available under DirectX APIs, Vulkan API, CUDA API, OpenCL API, OpenGL API, all kind of open source 3D rendering real-time APIs or commercial 3D rendering real-time APIs. This was the test without Nvidia ShadowPlay recording. Keep that in mind. DDR4 was running below 45 nanoseconds, probably the fastest possible DDR4 out there. Even when it was running 3200 megahertz, I still was using CL11, so not CL16, not CL14, CL11. The low value is better. So 15,000 megabytes read, write, and copy, almost as you can see. And for dual channel 128-bit DDR4, this is the great result. And how I achieved that, because I was running actually the Corsair DDR 5000 megahertz, 2500 megahertz times 2, 5000 megahertz CL18, but it wasn't stable on this Z390 motherboard. Okay, so just because it was running the Micron chips, I utilized this Micron chips to its best possible scenario, which is the lower latency but not the highest frequency. Samsung B chips on DDR4 technology was the best chips that was striving to the higher frequency. Okay, but CL11 3200 megahertz 1T command, this is unheard of, guys, as again below 45 nanoseconds, 50 gigabytes per second data transfer, or 50,000 megabytes. Dual channel 4 sticks, 8 gigabytes, which is the best possible scenario. No matter what sticks you're running in dual channel, single bank or dual bank, is still going to be great. 4 sticks in dual channel. Same amount of sticks, same gigabytes, same sticks. 48 multiplier and CPU cache frequency, which is 4800 megahertz CPU frequency, 4.8 gigahertz. And Titan RTX was overclocked as again. And let me show you. Right now, I was running faster than RTX 3080 video card. But usually Titan RTX video card, when it's running stock to stock RTX 3080 video card, RTX 3080 video card will be faster. Do that, it's going to have more bandwidth. It's going to have 769 gigabytes per second bandwidth, and this is the bandwidth when the Titan RTX is overclocked, so 20 gigabytes per second faster than bandwidth of the video RAM on RTX 3080 video card. And RTX 3080 video card is the better generation, a newer generation than Titan RTX video card. Keep that in mind. So you will see the difference in performance when I'm going to bring Titan RTX to stock on pixel fill rate, texture fill rate, and bandwidth. Let me demonstrate it for you. That's why the software overclock is crucial, especially for the Titan RTX. It's going to bring you at least 10% of the performance boost on average, which is great. As you can see right now, we lower pixel fill rate, we lower the textual fill rate, and I lowered the bandwidth, all right, by a lot. On the background, it was a track that all rights reserved, no royalties can be claimed, was provided by YouTube, called Commander Impulse Div Kit. All right, you cannot claim any royalties, as again. Alright guys, that's pretty much it. This video was recorded in December 2022. This technology was available in December 2018. There's going to be the first vertex of data, the first coordinate of data towards the 12K video resolution benchmarks in Dirt3 PC game throughout the all kind of different technologies that I'm going to benchmark over the UHDking.com. You just witnessed 12K UHD in Dirt3 PC game. Don't forget to smash that like button. A lot of time, money, energy was invested. Support me guys. And have a good morning, good day, good evening. Till the next time.